Hello and welcome back. Today we'll be looking into building a foundation for a location-aware app, and that is by having the right permissions. So you probably have interacted with apps that use location multiple times. So this could be, your weather app, just checking, will it rain today? Will it be sunny today in the area I'm in? It could be a cab hailing service, like Uber, Lyft, Free Now, and the likes. Or it could just be sharing your location with a friend or a family. There are two main ways in which your apps may use location. That is while in the foreground, which is usually used for like a limited amount of time. You don't always need it. Or it may be the screen that's in view. For example, you're having navigation directions in your car or something. The other way is in the background, and this is a location that's required constantly, or when you close the app, there's still location information being relayed. An example is maybe you're in a cab and you switch apps or are playing a game, and when you arrive, it kind of alerts you that, hey, you've arrived at your destination. That's one example of a background location at work. And in this video, we'll put our focus on the foreground. So let's get this show on the road. So when requesting permissions, there are a couple of things to keep in mind, and we'll go over them step by step. Permission handling initially is one of those things that can easily get confusing, especially with location permissions. And requesting foreground permissions is usually a bit more lenient than requesting background permissions. And this is due to security, privacy concerns. And also getting it through Play Store might require getting through more hoops than foreground location access. And for now, I'll only be talking about foreground location. And also a quick scan over the docs. There's one other thing which we need to know about location is how approximate do we want to be, how accurate do we want to be. And usually there's two groups to this. I'd say precise location and approximate location. And I mean, they're very explicit with the naming. Precise is very precise, and approximate just gives an approximate, going by the values here, 1.2 square miles, converted to kilometers, meters, whatever metric or measuring system rocks your boat. The other thing to keep in mind, or the only thing to keep in mind for now, is the names to the permissions that you're interested in, and that's access find location and access cost location. And this video will only be using one just to get this thing going, and that's the approximate permission. Depending on your Android version, how we request permissions will be different. As you shall see, for Android 6 or higher, that's API 22 and above, we will be requesting permissions during runtime, meaning when the feature is needed, that's when we actually ask for permissions. But for less than Android 6, they'll always have the permission at install time. I already have the perfect app to showcase this location capabilities. So this is the app I've been using in my previous videos. The link will be in the description. It's a simple weather app. What it does is fetches data from the Open Weather API, but the location it uses to fetch the data is hard-coded, and the city I put in is, my default city, which is Dusseldorf, and the goal will be to use the device's current location. And again, for this video, we'll only be focusing on adding permissions first, and in the next couple of videos, we'll see how this app will leverage location capabilities. And let's go. First thing, we're going to be adding the course location permission to the manifest. The next thing we need to think about is runtime permissions, and the best place to do this in our context is in the activity. This is where we set the content of our app. As I mentioned earlier, our app is built with Compose, and also the approach I've decided to go with is we won't show weather info if we don't have a location. First thing we need to do is check if we have the location permissions. I created a function called check for permission. So to check if permission is granted, there's a context compact class that has this check self permission method, which will pass in the permission we're interested in. That's the access cost location. Then we'll use the package manager constants to check if the permission is granted or not. Then we will give it two high order parameters. This will contain the logic for when the permission is granted or when the permission is denied. We'll then go ahead and use the function we just created in our set content block. When the permission is granted, we want to show our UI. And when it's denied, we'll have to check whether we should show our rationale. And what this means is we are checking if more info about the permission we are requesting for should be provided. And this usually returns true if it's been denied at least once. Next, we'll define the UI component that shows this rationale. I'll use an alert dialog for this. We are using compose, and we can only call composable functions in the context of a composable. So to fix this, I will annotate our high order functions from before with @composable. I will also annotate the whole function as well. Okay, this seems to be an error down here. I forgot to invoke this function from before. I'll fix that as well. Our composable functions have a naming format, I believe Pascal case. I'll edit this to follow the convention to remove this lint check warning, and we can continue from here. Next up, I'm going to fill out the alert dialog UI with text and buttons that handle granting and denying permissions. Next, we'll work on the logic for the buttons and the dismiss request. And I'll make use of state primitive types that come with Compose. That is, remember and mutable state. The idea is to show the dialog by default when show rationale is true, else we'll just close it when some other action occurs. Before we go ahead and request permissions, we will register a permission request callback, and this listens in on whether or not permissions were granted. Let's go. The next thing that I'm gonna do is, when we don't have permissions granted, we would love to show a different UI. I'll keep it basic for now, and it's going to be a composable. Okay, so we've ran into an issue. As I mentioned earlier, composable functions can only be called from a composable context. So we need to figure this one out, and that's where state comes in. Before we fix the state issue we just saw, let's use the callback we just used to request for permissions and have it triggered. And we'll start with the happy path of requesting permissions when the grant permission button is clicked. And we can also reuse this in the else block where we don't need to check for rationale. Then let's see how it looked like for the denied case. As we saw earlier, we can just call our composable functions from the callbacks. For us to effectively do this, we're going to make use of state. And I will create a variable in the compose context to do this. And we'll use this value to drive the UI. Whenever initial composition or recomposition happens, we'll build the UI based on the data we receive from the state. That is, whether we need to show the weather UI or show the permissions denied UI. We will also create a UI for the fallback screen when we don't have permissions. The idea is know whether data will be shown. Okay, let's run this and see how it goes. And we ran into an error, and it has to do with how we are registering our permission result callback. I believe moving this up a few levels will fix this and have it in the on create where it's registered even way before we need it. So it's a life cycle problem. This brings a set of other problems because we now don't have access to the variable we created before. Let's fix this. First, we'll delete this. Then we'll create a variable just to see how the permission flow works and have it going. Doing it this way has its own set of problems. We'll see why shortly. Let's run this. And our app runs, and we can see the runtime permission request UI for approximate location. That is if you're running on Android 6 or higher. Here you can either give the app access to the permission while you use it, or just with one-time permissions. This is available if you're on Android 11 or higher, or we could just not allow the permissions. Once I select on don't allow, we see the denied permission screen we created earlier. And when I come back to the app, we see the rationale. because we denied it before. Then when I click on grant permission, we should see the runtime dialog. And when I click on deny permissions, we should be taken back to our denied screen. And we have run into a bug. The dialog is not being dismissed, and it's because of the variable we created earlier. And this is because it doesn't send the data downstream, and you have to close the app and come back again to see the new state. It is not as reactive compared to other solutions, which we'll see. And the approach I'll use is observing a state from a view model. And when the callback receives a result, emit this value via the state property. So the app uses an MVI pattern to handle such actions. So I'll go quickly over this. Next, I'll create the state which we'll expose to the UI. I will then create an intent to request for permissions, and we will process it from the view model and set the state with the correct data. We'll then go back to our UI and make use of the state we just created in the view model. Change this to val. Then we can now make use of our view model process intent method from the callback. This ensures that our state gets updated every time our callback returns a result. We will then collect the state from the view model. This needs to be done from a composable context, so I'll move this in here. And we can check for the granted permission. Before we run this, we can do a bit of cleanup. Also, we are going to make use of the remember state for the dialog and display it when the state changes, or when a recomposition happens, then we'll hide or show the dialog as needed. Also, don't forget to clean up the if-else. At the bottom, we only need to check the state variable. And we should be good to go. And our permissions flow should be working as expected. When we grant permissions, all the flows work correctly, and when we deny permissions, all our flows should work correctly. The dialog also gets dismissed this time, and yeah, that's it. And that is all for this video. If you liked the content, please like, comment, and subscribe. And I'll be seeing you next time. Ciao.